already know how to do these, so you can go ahead and try them if you want, but if somebody can tell me what I do to solve the first one. So the reason why we're warming up is because when we get to the harder questions, it's really just doing a one-step equation over and over and over again. Like every step is the same. There's just more junk around it. I have to know how to write that. I have to know what order to do it, so it's a little bit more complicated, but the steps are still the same. So we're going to review that, refresh our memory on that, and then get into the harder stuff. So what do I do for the first one? What do you think? Anybody? Yeah, Mike. Subtract 3 from both sides. Well done. And again, we ask ourselves, is that actually gone? I'm trying to get it away from the x. Is that actually gone? 3, positive 3 and negative 3 makes 0, so that's good. And we don't have to write this step, but some people do like to. 15 minus 3, and 15 minus 3 is 12, so I'm done. Very good. Next one. Lexi, what do you think? Add 1 to both sides. So now we're leaving the x where it is and moving the 1 away from it. It's moving over there because I add a pound to both sides, which gets rid of that negative 1. And 5 plus 1 is 6 equals x. Done. Pretty good. Next one. Ask yourself, what is the operation that's happening to the x? Ryan, what do you think? Cancel out the 7. And what is the operation? This is dividing, so I want to multiply to cancel it out. Very good. I'm dividing by 7. You can say it, x divided by 7. Okay, I'm dividing. What's the opposite of dividing? Multiply. So we can show it like that. And 7 divided by 7, those are gone. You got to get used to that idea. 7 divided by 7 is 1, so it's gone. I don't subtract 7. That's not going to get rid of a dividing 7, right? And I get x equals negative 3 times 7 is negative 21. Okay, last one, last type. Sadie, what do you think I do for this one? So what's the, are we dealing with the 5? And then see how it's like, there's like layers of this, right? Okay, so first it's the 5. What's the operation? Sadie, do you know? Multiplying, very good. Awesome. It's negative 5 times x. So we do the opposite, which is, Corbin? Wait, I'm already timesing. I don't want to times again. What do I do that's the opposite? Good. Divide by negative 5 and divide by negative 5 on both sides. Those are gone. X equals negative 30 divided by negative 5 is negative 6. Get your calculator out for that. Don't let that be the mistake that you make. Some people do, 30 divided by 5, that's 8, right? You just make that mistake. So use your calculator if you're prone to making those kinds of mistakes. Right? Are you sure?
Oh, wait, yeah, it doesn't equal 6, doesn't it?
Yes. Sorry, I don't know why I wrote negative 6. Thank you. Yep, very good.
Isn't that a positive 6?
Yeah, it is. Okay, 2-step. So see, we're doing the same thing. I just have to do it twice. I have to know what to do first, the order to do them, that kind of thing, but it's the same idea. I'm trying to get the x all by itself. I got to get rid of all the junk that's with the x. What do I do first? What were you going to say, Ryan? Get rid of the 7. I'm adding 7, so I want to do the opposite, which is subtract 7. So I do that from both sides. Gone on this side. 3x equals negative 14 minus 7 is negative 21. And I hope you're getting familiar, you're getting comfortable and like recognizing that every time we end up with this something x equals something, and we just divide by whatever it is. Like every time that happens almost. So you get used to it and you expect it, you predict it's going to happen. And then you don't even have to think about it, you just do it. Corbin, what were you going to say? Tell me to divide by 3, and yeah, good thinking. Okay, one more. You could try it yourself, you don't have to wait for me. Ashley, what would you do for this one? Take away 4 from both sides. Very, very good. 20 minus 4, 16. 4 minus 4, gone. Miguel, what's next? And I get 16 divided by 2 is 8 equals 8. Done. Good, very good. I hope that's familiar, and even if you're not answering the question yourself, you're predicting what's going to happen in your head. You're thinking, I think you're supposed to divide by 2. Yes, okay, good. I'm glad I was right. Okay, you're thinking along the way. I think it's a good idea to write these steps down just quickly. It's a good little refresher. I'm going to talk about them a little bit. I'm going to give you a second to write down those steps. This is where we start some new stuff for today. That's right. That's step number 2. Letters equals numbers. We'll talk about that in a minute. Yep. Whenever you get to harder questions, you got to remember it's actually just a whole bunch of smaller, easier questions put together. But that's not to say that it's not hard. Like can still be hard to know which steps to do first and how to organize it and that kind of thing. So it can still be hard, but a really, really, really important strategy is breaking it down into those smaller steps and trying to do them one step at a time. Otherwise, we get overwhelmed. So here's a little hint. The very first step we don't have to do for example A. It's already kind of simplified, so we're going to see that in example B. So we don't have to do that part yet. Simplify both sides of the equal sign. We'll talk about what that means in a minute. Step number 2, this is what I like to remember. You could say this little phrase to yourself 100 times. Letters equals numbers. Letters equals numbers. Letters equals numbers. Letters equals numbers. What does it mean? It means you're trying to get all the letters on one side and all the numbers on the other side. Take a look at these examples we already did. Letters equals numbers. Letters equals numbers. Or numbers equals letters. Letters equals numbers. Letters equals numbers. Letters equals numbers, right? We're getting letters on one side and numbers on the other side. We're grouping all the things that go together with things that are similar to them. Okay? So what kinds of things in A are similar to each other? What do you think, Mike? Good, the X's. And what other kinds of things are similar? The numbers, right? Just the numbers. So the 7 and the 21. But they're on opposite sides of the equal sign. So I'm going to kind of scribble on this example. It's not how I would usually show my work, but I'm just going to try to show my thinking with some extra arrows and stuff. Okay, so you don't have to write it all down if you don't want, or just know that we don't do it this way every single time. So here's what I'm going to do. I'm going to get letters on the left, numbers on the right. Some people love having strict steps they follow every time. It means you don't have to think quite as much, which can make things easier. So if you're like that, always put letters on the left, numbers on the right, go for it. If that's a rule that you like that helps you, do it. Okay? I see basically no reason not to do that. Letters go to the left, numbers go to the right. So that's what I often do as well. So how do I move this to the other side? What do you think? Add 4x and add 4x. Very good. So it's still balanced because I've added the same thing to both sides. And I'm going to hold on. And I'm going to move all the x's to the left. Good. What do I need to move to the right? The number. How do I get rid of the 7? By subtracting 7. But I have to do the same thing from both sides. So again, I'm going to write out a little bit of extra stuff here. This is going to end up looking like 3x plus 4x, 7 minus 7 is gone, equals 21, and these guys are gone, and minus 7. Good? 3x plus 4x? How do you do this? Yes, 7x, that's right. But some people might be like, well, how is that? Yeah, it is literally as if you have 3 apples and then plus 4 more apples, so you have 7 apples. That's literally what it is. The number in front of the variable is telling you how many of that thing you have. I have 3 x's. I'm adding 4 more x's, so I have 7 x's. It's just the numbers, that's right. Yeah, that's exactly what it is. But really, this is an important skill. Okay, you do it, it's called like terms. You do it in grade 9. We're not doing a whole lesson on it. So if you have any questions, make sure you ask. We'll do more work with the x's as we go. And then 21 minus 7, we all know that.
So then would you divide the 7 by 7 and then do the 14 by 7?
Well, what do you think? Kareem, what do you think? Divide by 7, right? Always divide, and that last step by whatever's in front of the x. 14 divided by 7 is 2. Questions about that one? Okay, let's try B. So this one has the extra step, okay, where we already have some stuff on the same side of the equal sign that's like each other, that's similar to each other, that you can simplify. You don't have to do it this way. There are other small differences that you can do that will get the same answer, and they're fine to do it that way. But listen carefully. I'm doing it a certain way that I believe is the easiest way because it's the same every time. And if you do it this way, every question will feel the same and you'll remember it for longer and it'll be easier to remember and you'll always have these steps that will always work. That's what I try to give you. So even if the questions get harder, these steps will still work the same way they do today. And if you do it a different way, it just might mean you have to adapt a little bit as you go in some cases. Okay? So this is how I'm going to do it. I'm going to find things that are like each other, like the 5x and the negative 3x, and I'm going to add them together. I'm actually going to take a step and rearrange and show that they go together. This part you wouldn't have to do, but so it's 5x minus 3x, and then I still have the plus 10. And notice that I didn't change the side of anything. Those 3 things were on the left side, they're still on the left side. I didn't change anything, I just rewrote it so that I've got those 2 side by side. And then on the other side, nothing changes, so I just leave it. Oh, equals. So what is 5x minus 3x? Teo, do you know what it is? Yeah, 2x. And then plus 10 equals 8 minus 4x. And now, see, I simplified. Now it looks identical to the last question. And that will always happen if you do it this way. If you always simplify first before moving things around across the equal sign, you'll always get this kind of a question. And this is familiar because we did a bunch of this yesterday and we did some of it today. And so it's like the same every time. But this is where I was saying before, if you didn't really do the practice yesterday, you don't really understand what we're doing yesterday, now it starts to get overwhelming because now these questions are bigger and there's a lot more steps. You're like, oh man, I don't know what's going on here. Well, but if you did all the work and you nailed yesterday, this is just one extra little step, right? Okay, so let's see. I'm going to move the 10 and the 10 and move the 4x and move the 4x. And that way I get letters equals numbers. Remember, letters equals numbers, letters equals numbers. So this ends up being 2x plus 4x. You don't have to write that. You could just add them. And those are gone. and then 8 minus 10, and those are gone. There, letters equals numbers. 2x plus 4x is 6x. 8 minus 10 is negative 2. Hold on. Some people here would divide by 2 because it's a smaller number, and 6 divided by 2 is 3. But remember, our rule is you always divide by what's beside the x. So what happens here? Yes, you get a decimal. Now you could write it as a fraction. If you're good with fractions, fractions are nicer. You don't have to do it as fractions today. We will do fractions eventually. But it works out to negative 0.3. If you round, you should show that you rounded, but there you go. Any questions? We sure? Try one more. See if you can figure out what to do on the first step. I am asking the whole class, eh, Cor, not just you. That's okay. Fine. Just let's finish this one first, and then we'll get started on the practice. Okay, so remember, you can get this one started if you've got it written down. What are the steps? Look for things that are on the same side of the equal sign. Don't move anything yet. And see if you can add things that are the same together. On either side, both sides, one side, the other side. Ethan, can you tell me anything on the left side that's like the same that I can add together? No. Not sure? I've got a 2 minus 3x plus 4. What in there is the same? Ryan?
The 2 and the 4.
2 and the 4. Whoops. Do you see how they're the same? Because they're both just numbers, they're not x's. Okay, what else? What about on the right side? What can I add together? Mackenzie, do you know? Yeah, the 2x and the negative 4x are the same. So those guys can go together. Exactly. So 2 plus 4 is 6, and I still have minus 3x. Now what is 2x minus 4x? Again, you just do the numbers. So 2 minus 4 is negative 2. So it's negative 2x. The x's are still there. And then I still have my minus 5. If you understand the steps, but you have a hard time with the signs, like you don't know if it's a negative 5 or subtract 5 or a minus 2 or a plus 2x or what, that's okay, right? But you want to know that that's what you're struggling with. The steps for solving the equation you're okay with. It's the signs that's messing you up. And then we can talk about that and practice that more. Okay, so now this looks like all those other questions. So what am I going to do? Letters equals numbers. I'll move the 2x. And I'll move the 6. 6 minus 6 is gone. I get negative 3x plus 2x, which is just negative x. Negative 2x and 2x, you guys okay? Is gone. Negative 5 minus 6 is negative 11. What do I do here? We saw a question like this yesterday. Ryan, what do you think? Divide. By negative 1, you were right. Or just, you kind of just think I'm moving the negative sign, but what you actually are doing is dividing by negative 1, and you get x equals positive 11. So it was negative 11, it just flips to positive 11. Any questions?